Yes, so continuing with the passive pressure, continuing with the last lecture on Terzaghi's analysis. Now, the passive pressure that we have considered in the previous slide, okay, now this passive pressure, which will be basically comprising of three components. One will be in terms of gamma, second will be in terms of cohesion, third will be in terms of surcharge. Okay, so now again have a look at this equation. QF into B, 2 pp BC tan of phi minus 1/4 of gamma B square tan of phi. Now what I'm going to do, I'm just going to rewrite this entire equation, but over here this PP is going to be broken into three parts. Okay, so PP gamma, BC and T Q. Okay, now if I open this bracket and try to expand this equation, I will get 2 pp gamma plus 2 pc plus 2 pq plus dc tan of phi minus 1/4 gamma b square tan of phi. Now to simplify this, I am making certain modification. What I am doing, I am writing 2 pp gamma minus 1/4 gamma b square tan of phi as b into half gamma into b into n gamma. Now what is this n gamma? It's just a constant. This is a constant of equality, you can call it. To get this equal to this, I am introducing a constant n suffix gamma. Okay. Second term 2ppc, I am writing it as b gamma d again into a constant nq. This nq is going to make this entire thing equal to this. Similarly, third part 2ppq plus bc tan of phi is equal to b plus into cnc. Okay, so nc, nq and gamma are nothing but constants. So this is Terzaghi's bearing capacity equation for determination of QF stands for ultimate bearing capacity. We had studied all these denominations in the first lecture. Okay, so QF is nothing but ultimate bearing capacity. This is an equation given by Terzaghi for a strip footing, okay, or for a shell foundation. Okay, where NC, NQ and gamma are bearing capacity factors depending on angle of shearing resistance phi. Okay, so this is a table. What you can see here, there is NC, NQ and N gamma, and this is tabulated for various values of phi. Okay, from 0 it goes to 24, then 25 also there, you can see it here, then 26 and it goes on. Okay, up to around 50. Fine. So using just knowing the value of phi, you can calculate this NC, NQ and gamma, and then just substitute in this equation. Now this equation is very simple. CNC, gamma, df is depth of foundation into gamma into B into N gamma. So this becomes a very simple equation to find the ultimate bearing capacity. Now important points. Terzaghi's bearing capacity equation is applicable for general shear failure. It can be modified for local shear failure. What will be the modification? It will be in terms of mobilized cohesion. Cm will be given as 2/3 of C, and mobilized angle of friction, it will be given as tan inverse of 2/3 of tan of phi. Okay, so when you are going to use the Cm and C phi, okay, the factors will be written as Nc prime or Nc dash, like we call it, Nq prime and N gamma prime. These will be bearing capacity factors for local shear failure. The equation remains same. Only thing the factors are going to change. C is going to become Cm. Then phi is going to be phi m. Ultimate bearing capacity for square, circular and rectangular footing. So the same equation has been modified for three cases. Okay. So now this is our main equation. We are writing the equation for SBC. SBC we denoted as QNM. What is the relation between SBC and ultimate bearing capacity? SPC-QNF will be QF divided by factor of safety F plus surcharge. So we are doing the same thing. We are just taking QF as it is, dividing the first term QF by factor of safety plus surcharge. Then, based on the shape of the footing, the equation slightly modifies. Okay, so you'll have to memorize these equations because in numericals we'll be requiring these equations. Okay. Now, based on the first 3 lectures, I want you all to do a little bit of brainstorming, discuss with each other and answer these 2 questions. What is the primary difference in the failure patterns in the theory proposed by Basic and the theory proposed by Terzaghi for shallow foundation? Okay, first question. And second question is, why are we not considering active earth pressure for Terzaghi's analysis? Okay, I'm not mentioning about Terzaghi's analysis, but why is it not considered in the Terzaghi's analysis? Okay, these are my references. Stay home, stay safe. I'll be giving some more lectures, but tomorrow I'll be some more videos. Okay. Hope to hear back from you all. If you have any questions, post them.